guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we continue our work with arithmetic sequences. Today we're going to take a look at a different way to find partial sums of arithmetic sequences. So in a previous lesson we talked about finding the series or the addition of multiple terms in a sequence. And we're going to have a little bit of a shortcut here to find any partial sum of an arithmetic sequence. So a series from terms starting at 1 and going up to n is going to be equal to n times the average of the first and the last terms. So as we take a look at this equation, we should be familiar with this. This expression right here denotes a series with n terms, and then n would be that constant, the number of terms in the series. A1 plus a sub n over 2 would just be the average of the two terms, but we can use this formula and substitute this in. So this would be the first term, and this would be the last term of our sequence. So if we want to evaluate the sum, and here we see the sigma notation, meaning to add together the terms from 1 to 29 of 4n minus 1. What we could do is we could find each of the 29 terms in this expression and then add all of those together, which would be a little bit of a cumbersome process. What we can do instead here is we can use our formula for the series of the first 29 terms. So n would be 29 in this case, the n that we're going to use in our equation up here. The first term, we are going to need to find the first term. So the first term, we can go to the calculator. The first term would be 4 times 1 minus 1, which most of you guys can probably do mentally. But just to give you that example here, the first term would be 3. So we're actually finding the value of that term. Then the a sub nth term would be the 29th term. So we can find that value by substituting in 29 into the explicit equation given to us. And this would be 115. And then we can simplify this expression or evaluate this expression. So 29 times 3 plus 115 would be 118 over 2 would give us the series. So the series would be 1,711. So if we add together the first 29 terms of the arithmetic sequence, 4n minus 1, it'd be 1,711. Now, the other way that we could do this, if you take a look at the properties, we can check this by going through the properties of sigma notation. And so what we would get here is 4 times the numbers of 1 to 29, which I'm going to put in here real quick. So we're putting in each of the 29 numbers. Hopefully I don't make a mistake here. So 4 times each of the first 29 numbers added together, and then minus 29 times our constant at the end, 1. I just quickly went through all of the properties for summations, and we get the same number. Okay, so what we can see here is that this formula is a little bit quicker of a way of finding the value of a series that starts at 1 without having to find each of the terms individually or without having to add up some value of 29 terms here. So it's a much quicker way to find the value of this summation. Problem number 7 says find the sum of the first 75 positive odd integers. So in this case, we have kind of a statement, but not an expression in summation notation. We can write the summation notation, though, if this is going to help us. So the first 75 positive odd integers would be n starting at 1 and going to 75. Now we want positive odd integers. So positive odd integers would be like 1, 3, 5, 7, 9, and so on and so forth. So if this is our first term, and this is our second term, and this is our third term, we might be able to find a expression that gives us the value of each of these terms. So what we can see here is that these are going up by 2 every time. So 2n, but 2n would just give us 2, 4, 6, 8, 10, so on and so forth. This would be 1 less than 2n, so 2n minus 1. So this would be the summation notation for the sum of the first 75 positive odd integers. Now what I can do is take this expression and evaluate it. Instead of finding all of the 75 terms, I can evaluate it using the series notation, the partial sum notation. So the sum of the first 75 terms is going to be 75 times the average of the first and the last terms. So we do need to find our first term, which would be 2 times 1 minus 1, which you guys could do in your head, but this would be 1. The 75th term we're going to need as well, so we need the first term and the last term there. So 2 times 75 would be 150 minus 1 is 149. So then the sum of the first 75 terms can be found by evaluating this expression. And so that number would be 5,625. So here what we have is a shortcut. As long as we know that these are an arithmetic sequence, meaning that the difference between each term is the same, we can use this equation to find the sum of any given numbers within that sequence. And this looks like a good place to stop. As always, thank you guys for tuning in, and I'll see you soon.